Linear Inequalities video notes. Remember that problem about Miss Sheitlin wanting to become a cat lady? It looks like this. Miss Sheitlin has decided to pursue her dream of becoming a cat lady. She has saved $1,000 to spend on cat adoption fees. Adult cats cost $100 to adopt, and kittens cost $200 to adopt. What are all the different combinations of adult cats and kittens that Miss Sheitlin could adopt? And remember when we did this, we had X was the number of adult cats, and Y was the number of kittens. And when we did this, since she wanted to spend exactly $1,000, our equation was 100x plus 200y equals 1,000. And when we originally did that problem, we assumed that Miss Sheitlin wanted to spend exactly $1,000. It's probably more realistic to think that Miss Sheitlin wouldn't mind spending less than or equal to $1,000. I don't have to spend all of my money on cats. So keep in mind that this exactly $1,000 gives us an equal sign, versus if I wouldn't mind spending less than or equal to $1,000, that'll change my equation to become an inequality. So now it'll look like this. 100x plus 200y is less than or equal to 1,000. And if we think about this, this kind of frees up some options for us. So before we were only considering combinations of adult cats and kittens where I'd spend exactly $1,000. So for example, I could have 10 adults and 0 kittens, because 10 adult cats, well, 10 times 100, that's 1,000. But now we could think about, maybe I just want 9 adult cats. 9 adults, that's $900, which is under my $1,000 budget, so it's good. Or perhaps I just want like 1 adult and 2 kittens. This one is, well, 1 adult is $100 and 2 kittens is $400. That's only $500. That's under my budget. So this combination is also possible now. If I don't care about spending all of my $1,000, I have lots of new combinations to consider. Lots of new combinations that are possible, since I don't need to spend all of my money. So what I want us to do now is I want to actually graph this and see what it looks like. And we've got, remember that we've graphed this equation before. We've graphed 100x plus 200y equals 1,000 before. And we did that using what we know about standard form. And remember that x, we said this is the number of adult cats, and y is the number of kittens. And I'm just going to count by ones down here, so 2, 4, 6, 8, 10. And then I'm going to count by, space this out a little bit more. And remember when we graphed this before, we used our handy dandy find the x and y intercepts. If I plug in 0 for x, I'm going to get 200y is 1,000. 200y is 1,000. Well, that means y is 5. And if I plug in 0 for y, that 200y is going to cross out, so I've got 100x is 1,000, so that's 10 here. So now I can make my graph. I've got 10, 0 right there, and I've got 0, 5. Now I'm going to make my graph. So it looks something like this. And remember before that we had these different possibilities that we considered. We had 0, 5. We had 2, 4. That was a possibility. We had 4, 3. We had 6, 2. we had 8, 1, and we had 10, 0. And those were all our possibilities that we had before when we wanted to spend exactly $1,000. Well, this time though, we've thought about some other possibilities. We said, well, what if I just want 9 adult cats and no kittens? That's right here. We said, what about if I want 1 adult and 2 kittens? That's this point right here. And as you might be able to guess, all of the points that are underneath this red line, so for example, 1, 1, 0, 0, 2, 1, 3, 1, all of these different points here are possibilities for the different combinations of cats, adult cats, and kittens that I could get. And I've got all these different possibilities that weren't possible before when we wanted to spend exactly $1,000, but if we can spend under $1,000, these are all possibilities that work. So what we're going to do is we're going to shade in this side to show that anything over here is possible. And let's just test it out. Let's say I wanted to get 10 adult cats and 1 kitten. If I try this out, 10 adult cats and 1 kitten, I'm going to prove to you that this doesn't work. Well, 10 adults, that's 10 times $100, that's $1,000, plus 1 kitten, that's $200. This is $1,200. This is not possible. So anything on this other side, if you try any point over here, it's not going to work. So, but this shading shows us that any of the points that are on this side, underneath the red line, are possibilities of combinations. So now let's take a step back and we're just going to kind of do the math side of this. So now we're graphing linear inequalities, which we haven't done yet. You know how to graph lines, but now we're adding this shading piece in. So there's possibilities that aren't exactly equal to. So first thing that you need to know is that when we've got less than or greater than, the line is dashed. And what that shows is that it can't be exactly equal to. So this shows not equal to anything on the line. But if we've got less than or equal to or greater than or equal to, that's a solid line, which shows that it could be equal to anything on the line. So I'm going to show you what I mean. So I've got y is less than negative 2x plus 1. So first I'm going to graph this line. I've got my y-intercept of 1, down 2 over 1, down 2 over 1, down 2 over 1. I can go the other direction. And since this symbol right here, this is a less than, can't be equal to, so I'm going to make a dashed line through all these points. Now I've got to figure out my shading. And the way I figure out my shading is I might want to think of a possible solution. So, for example, I'm gonna test this point right here. I'm gonna test the point minus 5, 0. So if I test minus 5, 0, I've got an x coordinate here and a y coordinate there. And if I test this out for y is less than negative 2x plus 1, if I plug this in, okay, y is 0 less than negative 2 times negative 5 plus 1. Well, negative 2 times negative 5, that's positive 10. 10 plus 1 is 0 less than 11? Yes. So that means this blue point that I drew is a solution. And since it's a solution, all of the other stuff that's on the same side of the line also a solution. So I'm going to shade this side right here. Okay? Now, I'm going to prove to you that the other side doesn't work. So let's say that I had tested this point out. I tested out 6, 0. If I do 6, 0, I'm going to have 0 is less than negative 2 times 6 plus 1. Negative 2 times 6, that's negative 12. Negative 12 plus 1 Is 0 less than negative 11? No. So all of this stuff that's on the right-hand side is not a solution. Okay, let's try another example. So I've got y is greater than or equal to 3 over 4x minus 2. So I'm going to put a point right here at minus 2. And I go up 3 over 4. Up 3 over 4. Go the other way. And since this is a could be equal to, I'm going to make a solid line through these points. Solid means it could be exactly equal to. Now let's test out a possible solution. Let's test out 0, 0. Let's see if this works. So if I do 0, 0 and I plug it into my equation, remember my equation, or my inequality, I mean, y is greater than or equal to 3 over 4x minus 2. Then I'm going to have 0 is greater than or equal to 3 over 4x times 0 minus 2. Well, 3 over 4 times 0 is just 0. 0 minus 2, negative 2. Is 0 greater than or equal to negative 2? Yes. So that means that 0, 0 is a solution, and I'm going to shade this side. Let's try another one. Okay. So first I'm going to graph this. This is greater than, which means that the line is going to be dashed, not solid. I'm going to use my handy xy intercept thing to help me out here. So if I plug in 0 for x, I get minus 3y is greater than 18, so that's negative 6. If I plug in 0 for y, I have 2x is greater than 18, so that's 9. So I've got 0, negative 6, that's down here. I've got 9, 0, that's over here. Since it's not equal to, it's a dashed line. Okay, and I'm going to choose a test point. I like 0, 0 because it's easy to plug in. So if I plug in 0, 0 here, I've got 2 times 0 minus 3 times 0 is greater than 18. Well, 2 times 0 is 0, minus 3 times 0, that's just 0. 0 is greater than 18? No. So I don't want to shade the side with 0, 0 in because it's not a solution. So I'm going to shade this other side in. Okay, last one. Negative 2x plus y is greater than 6. Remember, we can do our handy finding x and y intercepts thing. So if I plug in 0 for x, y is 6. If I plug in 0 for y, x is negative 3. This is a less than or equal to, so my line is going to be solid. Now I'm going to choose my test here. I'm going to test 0, 0. It's my favorite point to test. So I've got negative 2 times 0 plus 0 is less than or equal to 6. This negative 2 times 0 plus 0 is just 0. Is 0 less than or equal to 6? Yes. So that means I want that to be a solution. So I shade in that side. And that means any point that's on this side of the line is a solution to this inequality.